guess what? This week we got results of the makeup of the Bennu asteroid sample that came back to us a few months ago. And guess what? We have here a press release from NASA that mentions NASA's asteroid Bennu sample reveals mix of life's ingredients. So what does that mean? They found on an asteroid the makeup or the building block of life that we have here on Earth, on an asteroid on space. So it has a lot of implication, especially for research, but also for people thinking about where is life coming from, or is there life somewhere else than Earth? So let's see if we can look at some of the information. It's quite amazing. So first of all, I have here, we have from Scientific Visualization Studio, we have some information that is interesting. So first of all, what do they mean by building blocks, life's building blocks that they found on Bennu asteroid? So here when they brought back the samples using, let's see, may as well talk about the mission a little bit. Let's see. So we have here in 2020, we had the mission OSIRIS-Rex that went to an asteroid Bennu. And here we have, let's see if we can show it a little bit. So we have here when it reached the ground, you see how dark it is. It touched the ground. It was much softer than they had expected, but they were able to bring back a sample. So that was quite amazing. Let's see if I can find another one. When it came back to Earth last year, they were able to get a canister and they were able to take samples from the different samples from the, let's see if I can, so here we have here the canister taken out, and you're going to say, how come you know there's no contamination on some of these samples? Look at these samples here. The reason for that is that it was sealed from space when it got to Earth. And here when we have the sample, the room to take care of the sample, they have negative pressure, so only air coming out, so no contamination. So that's first of all. And I think they brought back, I think it was 120 grams of materials from the Bennu asteroid. So that was quite exciting. Now, some people, some astrobiologists, we call them, they look at the samples. It was very dark, like coal, and they did some experiments to see what was the information they had. Now, they realized that we have on Earth about 20 amino acids, so molecules that make up protein on Earth. And they realized that out of the 20 that we have, the 14 have been detected on the sample from the Bennu asteroids. So here we have on Earth life. We're always trying to figure out how life started. But here we have from an asteroid, we have data now that shows that on that asteroids, we have molecules. So 14 out of 20 molecules that we find on Earth, that is the makeup of what we call protein. So that has been quite exciting. Now, you go into space, you won't create a human being just with those molecules. But the big question here is that can this give us a clue of what's happening? Now, keep in mind that this is a sample, a fresh sample from the asteroids. Over the history of the planet, if you think of the last, let's say the last few 100,000 years, when you have an asteroid coming to Earth and it's made of rocks like this, they burn in the atmosphere. So those proteins, no, those amino acids break down with the heating and the friction of the atmosphere. So when we pick up a meteorite on the ground, all of these have been damaged or they don't exist anymore because of the heat of the entry of those asteroids in the atmosphere. So finding a sample or studying sample from the Bennu asteroids, finding those amino acids is exciting. Now, on top of that, they mentioned that they did find also nucleotide bases. So what does that mean? So if you take our DNA is made of 4 basic building blocks and also phosphate section. So we have, so when I teach grade 9 and 10, we talk about the fact that the 4 building blocks in DNA is guanine, cytosine, adenine, and thymine in the DNA. So that means that we have here the building blocks of what goes in the DNA. That's exciting. So the materials. So if you take these asteroids made of materials from the beginning of our solar system, so they figure that these have been there for several billion years. We have here building blocks that were available at the beginning of our solar system. So what does that mean? That means that when we go back 4 billion years, 4.5 billion years, and we had the rocks, we had metallic asteroids, we had all this accretion like a protoplanet in our solar system, we had building blocks that were building. Now you have to keep in mind that 4.5 billion years ago, the outer part of our planet was mostly magma, and we had no hard surface really at the time. So 4.5, maybe 4.8 billion years ago, 5 billion years ago, that's a good question. So here we had blocks that were all merging together and brought some materials. If you go back that far, those materials were all destroyed, I'm sure, because of magma and because of the heat on the Earth's surface. But as soon as the surface of the planet started to cool down, we ended up with solid lithosphere. So we had I will call them continent, but we have, for example, in North America, let's see, le bouclier canadien. So the Canadian shield, for example, we had a crust of the planet. If it happened that we had materials that survived the beginning of Earth's protoplanet, or some input or intake of these materials before the atmosphere was burning these materials, there's a good chance that they were part of the building blocks that made life on Earth the way we see it. That's a good speculation, but that makes sense. Now, some of you will say, well, how can the solar system create these molecules? Well, that's a good question. In the reading I did this week, they were mentioning that if you think of our universe, in our universe, you have stars with explosion, and then you have new stars coming in through nebulas. What happens is that you have materials, so you have, let's see, atoms that will decompose and therefore will create heat through fission of their nucleus. And what happened here is that if you have different compounds and you have heat from the decomposition, from nuclear fission, that heat would create new molecules and over time will break those molecules. So what happens is that over billions of years, these new molecules being built, new molecules being destroyed, and the coming and going of these new molecules ended up creating these amino acids. How do we know that they are real? Keep in mind that if you're in space and it's very, very, very cold, the chances are that they are pristine to what we had at the beginning of the solar system. If it got too close to the sun, it was absorbed in the sun. All these molecules ended up being absorbed. But what's interesting here is that we have proofs from a lab that the building blocks of life, amino acids and here nucleotide, are part of this asteroids, and therefore it's something to look into. Oh yes, the other thing that they mentioned here is that they have also looked at the amino acids, and they have two molecules they talked about. One is L-serine, the other one is D-serine. And they mentioned that from what they've seen, they have equal quantity of them. One is left-handed and one is right-handed. So the same composition, but the arrangement is different. But what's interesting is that from what I've read, is that both are on the planet, but life grew from the left-handed ones. And that's what we find in the environment, in plants, and so on. And the D-serine molecule, the right-handed one, would be created through the metabolism in organisms like humans. So what happens here, the big question is, why did life evolve with more left-handed type of serine molecule more than the right-handed. That's part of the new questions that came through with the results we got this week. So let's see, this was this one here, ingredients. And I was wondering how big was Bennu. So Bennu is more or less spherical. It's about 500 meters in diameter. So that means that every time there's a collision with celestial bodies, there's enough gravity that gives it more or less a spherical shape. So I think that's exciting. So that's all part of what I wanted to show you today. We have data from an asteroid that has not been damaged with friction and entry in our atmosphere, and we found life's building blocks. Hopefully you're as excited as me. I'm gonna put a link to a video I did on the Bennu extraction of the sample I did a couple years back. You'll see, you'll enjoy. I'll see you there.